15 or 70 weeks or something like that to find out what is an operating system. So you tell me, what is an operating system? Strange thing, it's something you cannot define by a concept, but you can describe what it's doing. So in order to see what an operating system is, you actually have to look into what is an operating system doing. So it's not described by what it is, but what it does, right? So instead of saying what is an operating system, you could ask what services does an operating system offer? That makes it a little bit easier. How would you go about discussing that? If you've got this at the exam, what would be your strategy to answer that?
I would use the layered model.
Yeah, the layered model is very good because it distinguishes, it defines what are the functions, and it's put those functions in a specific order. So that would be a very good idea. That's why I wrote it in parentheses. Think about the layered model. So if we do that, what does an operating system look like? The kernel, yeah. And if you were to say something about the kernel, what does the kernel offer? At least.
There's a dispatcher.
Yeah.
Interrupt.
Yeah.
It manages.
Interrupt services or interrupt handling, and a process dispatcher, and
synchronization.
Exactly. Synchronization of the processes. So we have three. We can distinguish three basic functions in the kernel, which is the first level interrupt handler. When we say first level, it just means that it registers the interrupts, it saves the registers, and makes ready to call the proper interrupt service routine. So that's what's done. Then we have the dispatcher, and then we have the synchronization, and the synchronization is basically signal methods and wait methods. They could be called post, wait, signal, wait, or any kind of function which can signal that we require a resource or are waiting for something, and a signal to indicate that that the event we're waiting for has occurred, right? So that's the basic of the operating system, and at least a kernel will contain these three functions. If we look at a Linux kernel, there are more functions inside the kernel. But if we look at a mini kernel operating system, the synchronization, the dispatching, and the interrupt handling are the only things which are in a microkernel system. Yeah. Okay. Next layer.
Memory management.
Could be memory management, yeah. And what MNT, what does memory management do?
It manages physical memory, so we have room for more processes.
It manages physical memory, yes, and it also manages, if we have got virtual memory, it also manages virtual memory. So the memory management is probably a mapping of physical memory into a virtual memory, and then a system to manage the virtual memory so that processors do not need to know about the physical memory. In any modern operating system, that's very important, that the processes do not know about physical memory, but only refer to memory as a resource which is then managed by memory management. And the basic thing in memory management, the basic mapping, what is that? How do we do the mapping between physical memory and virtual memory?
Pages.
Pages, exactly. So we have pages in both systems, and then we have a mapping mechanism which is a piece of hardware in the middle which maps physical memory into virtual, or rather maps virtual memory into physical memory. Yeah, which means that every virtual page do not need to have a reserved physical page. We can allocate a physical page whenever we need access to the virtual page. Yes, we'll look into that a bit later, some of the other questions. So, but this is enough for now, just discussing the functions. The next layer then, probably.
And the drivers, the IOC.
The drivers, yes, and in general we have a term for that saying that's the input-output control system, because the drivers are managing the physical devices. The input-output control system also contains some buffer management, so when we need buffers to communicate with devices, the buffer handling is also part of the input-output control system. But the main part of it, the input-output control system, are the drivers for all the devices we have in the system. Yes. And now that we have a memory management system and we have an input-output control system, we can actually build a file system. Do the layers always have to come in this order? Can you change the order of any of those layers? No. You would probably need an input-output control system with drivers before you can build a file system. But what about memory management and input-output control? Sorry?
They will be in the same layer.
Yeah, I wouldn't do that because these functions are very different from these functions. But you could switch the order. You could have the input-output control system right on top of the kernel, and it is in some operating systems, or you could have the memory management system right on top of the kernel. It differs. You can have two different strategies. If you build an operating system based on this order, then the input-output control system has access to virtual memory. But if you do it the other way, the input-output control system do not have access to using virtual memory. Then you have to build the input-output control system using physical memory. So you would have to administer the memory yourself in your input-output control system. So the important thing is that any layer can use services by layers offered by layers below it. It can never use services from an outer layer because that doesn't exist when you build the layer. It also means that you can take out the layer and replace it with another layer offering the same functions. You should just make sure that a new implementation will always offer the same services as the old implementation, plus maybe something more. That's important also. Yes. So if we look at the Linux kernel, it constitutes all layers from this inner kernel, memory management, input-output control system, and file system. So the file system is also part of the kernel in a Linux system. Except if we're looking at use of Linux, which we will implement on many systems now. Yes? the last thing, which is then not part of the kernel, so now we can define last layer. Or the bash, which is generally the shell. So this is where applications work, and this is also the level where the shell works. So the shell is a number of pre-programmed applications which allows you to do a lot of things. You can copy files, you can rename files, you can change the date of a file and things like that. So you have a number of standard utilities, which is the shell, and then if you cannot build an application based on all of those standard functions offered by, or standard services offered by the shell, then you have to do some of the programming yourself, and then you program applications. But in many cases, you can actually build a whole application using just pre-programmed shell functions. Communicating through, how can shell functions communicate?